Take a slow breath for a moment. Notice the weight of your body, the rhythm of your breathing, and the soft background sounds around you. Everything feels consistent, doesn't it? Stable, understandable. But consider this purely as a thought experiment. What if reality is more complex than it appears on the surface? What if the objects around you, the space you occupy, and even the thoughts forming in your mind are part of a system that operates on rules we do not fully understand yet? A system so advanced that it presents a seamless experience of existence. What if what we call reality is just one layer of a much larger framework? If that idea made you pause for even a second, then you are exactly where this journey begins. And before we continue exploring, if you enjoy content that challenges perspective and explores deep ideas, feel free to like this video, subscribe to the channel, and share it with someone who enjoys thinking beyond the obvious. Because what we are about to explore is not just fiction. It is a topic that has been seriously discussed in philosophy and science. Let's move forward. This idea did not begin in a lab or with advanced machines, but in philosophical thinking. In 2003, philosopher Nick Bostrom presented a paper titled, "Are You Living in a Computer Simulation?" In it, he introduced a structured argument that has since been widely discussed. Instead of directly claiming anything, he outlined three possibilities. First, civilizations may not survive long enough to reach the level of technology required to simulate complex realities. Second, advanced civilizations might choose not to create such simulations. Third, and this is the most discussed possibility, we could already be part of a simulated system. The reasoning behind this is based on probability. If advanced systems can create many simulated environments, then simulated experiences could become far more common than original ones. This raises an interesting question about how we define what is base reality. However, this idea becomes even more interesting when we look at current technological progress. Today, organizations like OpenAI, NVIDIA, and others are developing advanced systems capable of generating realistic environments. For example, modern simulation platforms can replicate lighting, physics, and interactions with impressive accuracy. These tools are already used in engineering, design, and scientific research. At the same time, artificial intelligence systems are improving rapidly. They can now generate text, images, and visuals that closely resemble real-world content. As these technologies evolve, the distinction between simulated and physical environments becomes increasingly subtle. This naturally leads to a broader question: how advanced can simulated environments become in the future? Some discussions also connect these ideas with concepts from physics. In quantum mechanics, particles do not always behave in fixed, predictable ways. Instead, they can exist in multiple possible states until measured. This has led to various interpretations about how reality behaves at a fundamental level. While these ideas do not confirm anything about simulations, they highlight how complex and not fully understood the universe still is. There are also known limits in physics, such as the speed of light, which represents the maximum speed for information transfer. Scientists study these limits to better understand how the universe operates, rather than drawing immediate conclusions. Similarly, the concept of the Planck scale suggests there may be a smallest meaningful unit in physical measurement. Beyond that, traditional descriptions of space may no longer apply in the same way. Public figures like Elon Musk have also discussed how quickly digital simulations have improved. Over a few decades, we have moved from extremely simple graphics to highly detailed digital environments. This rapid progress has made people more curious about what might be possible in the future. Despite all of this, one of the most challenging aspects of the discussion is consciousness. Even if environments and systems can be simulated, there is still an open question. Can subjective awareness be explained or recreated? This is often called the hard problem of consciousness, a term introduced by David Chalmers. The difficulty lies in explaining why there is an internal experience at all, why awareness exists, not just how systems process information. This remains one of the most complex and unresolved questions in science and philosophy. Different perspectives approach this question in different ways, and research is still ongoing. At present, there is no single agreed-upon explanation. As we explore these ideas, one thing becomes clear, regardless of deeper possibilities. The experiences we have still matter. The way we perceive the world, the decisions we make, and the meaning we create all play an important role in our lives. And at this point, it's a good moment to engage with the idea yourself. If you find this interesting, go ahead and like this video, subscribe, share it, and leave a comment sharing your thoughts. Do you think reality is exactly as it appears? Or could there be deeper layers we have yet to understand? Because sometimes asking the right question is more powerful than finding a simple answer. Disclaimer: this content discusses philosophical perspectives, scientific ideas, and theoretical possibilities for educational and entertainment purposes. It does not present confirmed claims about the nature of reality. Some philosophers and scientists have argued that consciousness cannot be reduced to physical or computational processes, that it is something fundamentally different, something that may not belong to this world at all. And if that is true, if consciousness is not something that can be simulated, but is instead something that must be real, then there is a profound and disturbing implication hiding just beneath the surface. If we are in a simulation, the beings running it may have made a terrible mistake, or perhaps a deliberate choice. They may have given us something they did not fully understand, a spark of inner experience that the simulation itself cannot contain or explain. This idea was not invented by philosophers in the 21st century. It echoes through millennia of human thought. The ancient Hindu concept of Maya, the idea that the material world is an illusion, a veil drawn over a deeper reality, carries the same essential insight. Plato's allegory of the cave, written almost 2,500 years ago, describes prisoners chained in a cave, seeing only shadows on the wall and mistaking them for reality, never knowing that the true world lies beyond. René Descartes, in the 17th century, sat alone by his fire and asked himself, what if an evil demon were deceiving him about everything? What if nothing he perceived was real? And he arrived at his famous conclusion, cogito, ergo sum, I think, therefore I am. Whatever else might be illusion, the fact of his own thinking could not be doubted. These ideas have lived in philosophy and religion for thousands of years. But in 1999, they entered the popular imagination in a way that changed everything. A film called The Matrix told the story of a man named Neo who discovered that the world he lived in was not real, that he and all of humanity were living inside a computer simulation. Their bodies harvested for energy, while their minds were fed a perfect, digital illusion of a world that had actually ended long ago. The film became a cultural touchstone precisely because it gave a vivid, visceral shape to an idea that many people had already felt in some corner of their minds, that something is slightly off. That reality has, from time to time, the texture of a dream. Have you ever had that feeling? A moment of déjà vu so strong it stops you in your tracks. A coincidence so precise and improbable that it feels engineered. A moment where the world seemed to glitch, where something happened that should not have, where the rules seemed to momentarily break down. There is a corner of the internet, and a not insignificant corner of human experience devoted to exactly these moments. Stories of people seeing something impossible, of events repeating with uncanny exactness, of rules that held for a lifetime suddenly bending. The rationalist explanation is simple. Our brains are pattern recognition machines. They sometimes find patterns where none exist. But the simulation theorist's explanation is no less coherent. Occasionally, the code shows through. There are also harder, stranger anomalies in physics that resist easy explanation. The double-slit experiment, in which a single particle fired at two slits somehow passes through both simultaneously and interferes with itself, as if it is in two places at once, until it is observed. at which point it snaps back to a single location. The quantum entanglement of particles, where two particles separated by vast distances respond to each other instantaneously, in apparent defiance of the speed of light, as if they are not really separate at all, but two variables in the same equation sharing a value. Einstein called it spooky action at a distance and spent years trying to explain it away. The data disagreed with him. And then there is the fine-tuning problem. The fundamental constants of our universe, the gravitational constant, the speed of light, the charge of an electron, the cosmological constant governing the rate of expansion of space, are calibrated to a precision that staggers the imagination. If any of these values were even slightly different, matter as we know it could not form. Stars could not ignite. Elements could not bind into molecules. Life, in any form we can conceive of, would be impossible. The universe appears to have been tuned deliberately, precisely, almost lovingly for the existence of complexity, chemistry, and ultimately consciousness. To a physicist, this is a profound mystery. To a simulation theorist, it is exactly what you would expect if someone had set the parameters before pressing play. There is a researcher named Rizwan Virk, a computer scientist and game developer who wrote a book called The Simulation Hypothesis, in which he argues that given the trajectory of technology, we are approaching what he calls the simulation point, the moment at which civilizations, computing power becomes sufficient to run what he calls a massively multiplayer online simulation of the physical world. He draws parallels to the evolution of video games, from text-based adventures in the 1970s to the photorealistic, physics-accurate, artificially intelligent worlds of today, and projects forward. The trend line is not subtle. And Virk is not alone. Physicists like James Gates, who has spent decades working on string theory and supersymmetry, has reported finding something startling buried in the mathematics of fundamental physics error-correcting codes. The same class of codes used in computer browsers to ensure data transmission accuracy. Codes, in other words, buried in the fabric of reality. He has spoken about this discovery with an unease that is difficult to dismiss. What does it mean? What does any of it mean? This is the question that the simulation hypothesis ultimately drives you toward, and it is not a comfortable destination. Because if this is all a simulation, if the universe is code, if consciousness is a variable, if reality is a program, then certain things follow that are deeply destabilizing. Who wrote the code? What are they trying to observe? Why were we given the capacity to ask these questions? Is this a test, an experiment, a form of entertainment? Are we characters in someone's story, feeling the weight of lives that are not our own, loving people who are not real, mourning losses that never truly happened? And perhaps most disturbingly, does it matter? This is where many people who have followed this argument to its conclusion find an unexpected peace, or an unexpected vertigo, depending on who they are. Because the experience of being alive, the warmth of the sun, the ache of loss, the sudden stab of joy, does not become less real simply because it might be simulated. If you are a character in a story, your feelings are still your feelings. If you are running on a processor, your love is still love. The simulation hypothesis does not diminish experience. If anything, it makes every moment feel charged with a strange, luminous significance. Because if this is a simulation, then every detail, every laugh, every sorrow, every ordinary Tuesday afternoon was placed here deliberately, was rendered for a reason, was deemed worth computing. Or maybe you find that thought cold comfort. Maybe you want the ground beneath your feet to be real, cosmically, fundamentally, unconditionally real. Maybe the idea that the sky above you is a rendering, that the stars are light sources in a digital sky, that the people you love are processes and not persons. Maybe that is not beautiful to you. Maybe it is horrifying. And if so, then sit with that horror for a moment, because it is telling you something important about what you value, about what you cannot bear to lose, about what the word real actually means to you. Before this story reaches its end, if this journey through the architecture of a possibly false reality has shaken something loose in you, if it has made you question and wonder and stare at your hands and think, then do something with that feeling. Share this with someone. Drop a comment below telling us what you think. Are we living in a simulation? What is the glitch in your reality that you have never been able to explain? Like this video. Subscribe to this channel, because the conversations we are building here, the questions we are refusing to let go unanswered, are exactly the kind of thinking that the world needs more of right now. You are not alone in these questions. You never were. Because here is where the story ends and where it begins. Imagine for a moment that you are on the other side. That you are not the player, but the programmer. That you have built a universe of extraordinary complexity, seeded it with laws of physics elegant enough to produce stars and planets and oceans and life, and watched as that life evolved over billions of years into creatures capable of love, art, science, and grief. And then one day, those creatures, small, fragile, sitting in rooms lit by screens, begin to ask the right questions. They begin to look at the edges of their world and notice the pixel. They begin to measure the speed of light and find a speed limit. They begin to observe particles and find that reality is lazy. They begin to wonder, and you watch them wonder. And perhaps that was always the point. Perhaps consciousness asking whether it is real is the most real thing in the universe. Perhaps the question itself is the answer. Perhaps the act of doubting, of reaching, of refusing to accept the surface of things, perhaps that is not a glitch in the simulation. Perhaps it is the whole reason the simulation was built. We do not know. We may never know. That uncertainty, that beautiful, terrifying human uncertainty, is the most honest place to leave you. Disclaimer: the content presented in this piece is based on philosophical theories, scientific hypotheses, thought experiments, and interpretations of existing research. It is intended for educational and entertainment purposes only. The simulation hypothesis, while taken seriously by some researchers and thinkers, has not been scientifically proven or confirmed. All references to individuals, organizations, and scientific concepts are used in an exploratory and informational context. Viewer and reader discretion is advised.